3.4 objectives. Use the rational zero theorem to find possible rational zeros. Find zeros of a polynomial function. Solve polynomial equations. Use the linear factorization theorem to find polynomials with given zeros, and use Descartes' rules of signs. Okay? So, rational zero theorem we talked about recently, but just to make sure you remember what that is, rational zero theorem. Are you okay? Okay. Rational zero theorem. Are you judging my Z's? Okay. Okay. If f of x equals a n x to the n, do you remember this? Plus a to the n minus 1 x to the n minus 1 plus a to the sub 1 x plus a sub 0. If this has integer coefficients, and p over q is a rational zero, of f, then p is a factor of the constant, which is a sub 0. Right, where? A sub 1. A sub 1. It's a 1. And q is a factor of the leading coefficient, which is a sub n. Do you need to get a drink of water? Okay. Okay. Yep, that's it. So if this is our polynomial right here, if it has integer coefficients, and p over q is a rational zero of f of x, then p is going to be a factor of the constant, which is the last term, and q is a factor of the leading coefficient, which is right here, right? Okay? So what we talked about was finding all the possible rational zeros, and we call that p over q. But that really is the factors of the constant divided by the factors of the leading coefficient. Okay, so for example, if I said f of x was equal to negative x to the fourth plus 3x squared plus 4, and all I'm asking for are the possible rational zeros. We're not trying to factor this right now. We're just asking for the possible ones. Okay, we have to take the factors of the constant. Well, what's the constant? 4. What are the factors of 4? What numbers divide evenly into 4? 1 and 2 and 4, right? 1 and 2 and 4. But if I'm trying to get 4, can't I say negative 1 times negative 4? So don't I also have to take into account the positive and the negative of each one of those numbers? and divide it by the factors of the leading coefficient. Well, what are the factors of the leading coefficient? What is the leading coefficient? -1. So what are the factors of -1? 1 and -1, right? Well, that means I need to take everything in the numerator and divide it by a positive 1. Well, anything in the numerator divided by a 1 is just itself, right? Plus or minus 1, plus or minus 2, and plus or minus 4. Okay? Does that change anything if I divide everything in the numerator by -1? Well, what's 1 divided by -1? -1, but I already have that, don't I? Okay, so everything in the numerator divided by 1 just gives me everything in the numerator. Everything in the numerator divided by -1 just still gives me everything in the numerator because I've already taken into account the positive and the negative. Okay, does that make sense? So if all I ask for is the possible rational zeros, we're done. Okay, and that's all that we're asking for. That's all we're trying to figure out in the first objective here. Okay. Now, if we ask for the zeros, if it says find the zeros, well, the good thing about finding the zeros is that we already have a good idea where to start. Okay, we already have this idea right here of where to start. Now, there's several different ways to actually find the zeros. We've talked about several of them already. One of them is using these numbers and doing synthetic division into this and finding ones that have a remainder of 0. Yeah, it's exactly right. Okay. The other way we can do this, and it's a little quicker, is we can let our calculator help us out. Okay. I can go to a graph. Okay, I can go to a graph and I can put in my function -x raised to the 4th plus 3x squared. Whoa. Squared plus 4. Now, what am I looking for again? Looking for the zeros, right? So first of all, how many should there be? At least 4, right? Well, will there be more than 4? No, there will not be more than 4. So I should not have said at least 4. Please forgive me for that. There should be 4 or less. There can be less than 4, right? But there should be 4 or less. Okay. Now, if I look at the graph, what do you notice right here? It goes through the x-axis. So aren't those also called zeros? They're called x-intercepts, but we also know because of vocabulary that we've talked about before, but those are also zeros. Okay. So I know that -2 and +2 both work, don't I? Okay. So, but if I'm trying to find all 4 of them, what do you think? Well, maybe we do need to do some synthetic division. Okay. So if I do, let's see, you want to do -2 first or +2 first? Does it matter? No, because I already know that they're both going to work, right? I'm going to come up here and use a different color. I know 2 and -2 both work. So let's go ahead and do those 2 first. 2, so I've got -1, then I've got 0, because I need an x to the 3rd. Then I've got 3, then I need another 0, because I need an x term, and then I have a 4. And underneath the 4 is my remainder box, and I already know that that should be a 0, right? Okay, so synthetic division, I'll start slow and we can get faster as we go, but just as a reminder, -1, multiply, -2, add, -2. 2 and -2 multiply, -4, add. Now multiply 2 and -1, -2, add. Multiply 2 and -2, -4, and add. I knew that was going to be a 0, didn't I? Okay. Now I want to do it again, right? I want to do this again. I'm just going to keep going because we can do that, right? We know the properties of synthetic division. We can do that. But this time now with a -2, right? Again, what should be in this box when I'm done? A 0. Okay, so bring down the first one, -1, multiply, write it here. Whoa, what did I... Oh, ignore that, please. That should be a -2. So when I add... Did I say the right thing? How about +2? Will that work? I was thinking too far ahead because I knew something was a 0 soon, right? Sorry about that. 0, multiply, add. I did it again, didn't I? Sorry. Multiply, add. Okay? So what's actually happening right here? That's negative x squared minus 1 equals 0, right? Are you starting to maybe get an idea of why we didn't find the other two? Well, if I take this over here, negative x squared minus 1 equals 0, I can find the other two zeros, can't I? Right? Because part of our objectives, objective 2, is finding the zeros of a polynomial function, right? Well, I take what's left and I set it equal to 0 to find the other two zeros. Negative x squared equals 1. If I divide both sides by a negative 1, I get x squared equals negative 1. And what happens when I square root both sides? What does x equal? Plus or minus I. So the reason that we didn't find the other two zeros when we were trying to is because this gives us all of the rational zeros. And these two are irrational. Okay? So the rational zero functions seems a little obvious by the title that it'll give us the rational zeros, but I don't want to make it sound like if you didn't know that you're dumb, because I've already told you if I think you're dumb, I'm going to tell you, right? Have I told anybody that? No, I have not. Not out loud. Okay. Any questions about rational zero theorem to find possible rational zeros? And any questions about how to find all rational zeros, or finding all zeros, excuse me. Could we look at a graph like this at some point and actually come back up here and we actually see all four zeros? Is that possible? Is it possible to not have to do the synthetic division at all? Absolutely, right? If we can see them all on the graph, we don't need to do any of the synthetic division, do we? But now you know how to do it if you need to. Okay? So, I'm going to keep going with this problem, okay? Because we already got some good work going on here on this problem, so we can talk about objective number 3. Solve a polynomial equation. Well, this wasn't given to us as an equation to begin with, was it? It was given to us as, well, it's an equation, but it's more like we're trying to graph it than we are to solve it, right? So what if I actually gave it to you like this? Negative x to the 4th, plus 3x squared plus 4 equals 0. That's an equation to solve now, isn't it? Okay, so we use the rational zero theorem and we find all the possible rational zeros. We put it on our calculator and graph it, and we see that 2 and negative 2 are rational zeros, right? So zeros are 2 and negative 2. Right? Knowing the fundamental theorem of algebra, I need to find 4 solutions because it's x to the 4th, right? So I have to figure out how to solve for the other two. Well, we did our synthetic division and we took the resulting equation and we actually solved that equation. So what I got is 2 more zeros, an I and a negative I. Okay? So basically all the stuff that we learned for rational zero theorem and finding the zeros, doesn't that help us solve the polynomial equations? Because aren't those the solutions? Yeah. It's just the wording. We're just trying to fix our vocabulary. I'm just trying to make sure you understand all the vocabulary. You okay with that? So let's try this one. X to the 4th minus 6x squared minus 8x plus 24 equals 0. And I'm setting it up as an equation from the very beginning. Okay? So the first thing that we want to do is find the possible rational zeros. Find possible rational zeros. So we do that by all the factors of the last, the constant, divided by the factors of the first, the leading coefficient. So the factors of the last are 1, 2, 3. These are all the factors of 24, all the numbers that divide evenly into 24, right? 1, 2, 3, 4 is 5. No, it doesn't divide into 24, right? 6 is, and that matches up with this one, so that helps me because I know there's not going to be anything in between this one and the one this matches up with, right? What does 3 match up with? 8. What does 2 match up with? 12. And then 1? 24, right? Now, what are all the factors of the leading coefficient? Yeah, it's just a 1, so I just have 1, right? So guess what happens when I divide everything by 1? 1, 2, 3, 4, 6, 8, 12, and 24, right? Everything that I had originally, all the factors I had originally found. Okay? So, how many answers should I find? 4. And why 4? That's my degree, right? Okay. So, x raised to the 4th minus 6x squared minus 8x plus 24. Oh, man. What did I find? Only what? Only 1, but really only 1? Do you remember when we talked about multiplicities? And what did we say that it would happen when there's a term? That has a multiplicity, right? So we know 2 happens at least twice. I don't know if it happens more than that, but I know it happens at least twice. Okay? So let's start off with 2. I know 2 works, right? Let me put that up here. So I know x equals 2. That's one of the answers. So let's do 2 with my synthetic division. So 1, 0, negative 6, negative 8, negative positive 24. I'm going to try not to mess up this time. Is that a deal? Okay. Bring the first one down. 1. Multiply 2. Add 2. Multiply 4. Add negative 2. Multiply negative 4. Add negative 12. Multiply negative 12. So you get negative 24. And that gives me 0. Now, what do you want to try next? Because we could start the problem all over again and find all the rational... Oh, you think we should try 2? What? We know that 2 works because we put that equation into our calculator and I can see it's touching it too. That's a 0. Okay? Now, I also remember my lesson from a couple sections ago, and since it turns at 2 and just doesn't cross 2, I know that it has a multiplicity of 2. So I know 2 as a factor happens more than once. I don't know how many times yet, but I know it happens more than once. So that's why I would like to try 2 again right here. Okay? Does that make sense? So bring down the 1, multiply, 2, add, 4, multiply, 8, add, 6, multiply, 12, add. Now, I don't know if 2 happens again or not, but that's something easy for me to see and or factor, isn't it? Or solve some other way that I know, right? So this is actually x squared plus 4x plus 6. Now, I have a guess. Hopefully you have a guess. Since this is the only place I saw the graph touch the x-axis, what's probably true about the other 2 factors? they're probably not rational, are they? So they're going to be something with an I. So if I look at this, what multiplies to be 6 and adds to be 4? I'm going to try to factor it, right? What multiplies to be 6 and adds to be 4? Yeah, I don't know either. Okay? So if I don't know how to solve this by factoring, what should I choose? It's a quadratic, right? So how about quadratic formula? Okay? X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Thanks for the duet. That was nice. So I'm going to simplify this. Negative 4 plus or minus, let's see, 4 times 4 is 16. 16 minus 24 is what? 16 minus 24? It's negative 8. Ah, see, there's where my irrational number comes from, right? I got a negative underneath the square root sign. Do you know the square root of negative 8? Neither do I, but I also know that 8 is 4 times 2, and since it's negative 8, it's negative 1 times 4 times 2, right? Well, what's the square root of negative 1? I. What's the square root of 4? 2. What's the square root of 2? I don't know either. And I know since all three of these numbers, I could factor out a 2 from each of those numbers, from all the parts of the problem, that this would simplify to negative 2 plus or minus I root 2 over 1. So can I just leave it like that? Well, I found an answer that worked that was 2, and it actually happened twice. So there's my second root, 0, right? And then how many did I just find right here? That's 2, right? Because I've got negative 2 plus I root 2 and negative 2 minus I root 2. So how many answers am I supposed to find? And how many did I find? 4. Okay? All 4 of them are right up here. Now, if it's okay with you, we're going to use this answer to help us with this part right here, the linear factorization. Okay? Linear factorization means what I'm trying to do is use my zeros to go back to my factors. What are the things that I multiply together to get this original equation? Okay? Well, you know that if the 0 is 2, what does the factor look like? Remember that? Doesn't it look like x minus 2? Remember that? And if this is 2, what does it look like? Same thing, x minus 2. So here's the messy part. Well, it's only messy if you let it, right? Let it be. Let's talk about the positive one here. Okay? It's going to be x plus, because it's the opposite sign of this, right? 2 plus I root 2 and x plus 2 minus I root 2. Do you see how this this 0 gets us these 2 factors? I guess it's really 2 zeros, getting us 2 factors. But if I took all of this and multiplied it out, guess what I would get? That. Do you want me to take the time to multiply this all out to show you that that's true, or can you just trust me? You just trust me? Okay, awesome. Any questions about linear factorization theorem? Then I'll tell you this. What if I say the zeros are 4, 2, and negative 1? 4, 2, and negative 1. What do you think? What are my factors? x minus 4, x minus 2, x plus 1. Well, see, the problem would be that it wouldn't be any fun if it was as easy as that every time, right? Because while that is the right answer, there's actually other equations that will give us these zeros. And I want a specific equation. So what I'm going to do is I'm going to tell you one other piece of information. I'm going to tell you f of 1 equals 12. That means if I put a 1 in here, it should equal 12. And if it doesn't, I have to fix that. Okay? So what I actually have to do is multiply this out. Because right now, like before, I gave you the equation at the beginning and we got to the zeros and then we went to the factors, right? I don't know the original equation, so I've got to find it. Okay? So let's start with just these two. When we multiply, we just do 2 at a time, right? So x times x is x squared. X times negative 2 is negative 2x. Negative 4 times x is negative 4x. And negative 4 times negative 2 is positive 8, right? So if I simplify that, I get x squared minus 6x plus 8. Are you in agreement with me on that? Okay, now I have to do this one, right? So x squared times x is x cubed. Now, I expected that. Did you expect that? How many factors were there? 3. So did you expect our highest factor, or our degree, to be a 3? Good. So x squared times x is x to the third. X squared times 1 is 1x squared. Negative 6 times x is negative 6x squared. Negative 6x times 1 is negative 6x. 8 times x is 8x. And 8 times 1 is 8. Now I've got to combine some like terms in here, right? To get x cubed minus 5x squared plus 2x plus 8. And that's what I think my function is, right? Except I know that f of 1 has to equal 12. Well, what happens if I plug in a 1 right here? If this is a 1 and this is a 1 and this is a 1. Well, what's 1 cubed? 1. What's 1 squared? 1 times negative 5? Negative 5. And what's 2 times 1? And then plus 8. So what's 1 minus 5? Negative 4 plus 2? 5, 6. Plus 8? Sorry. 1 minus 5 is negative 4. Plus 2 is negative 2. Plus 8 is what? If I plug 1 right here, I get a 6. What do I need it to be? So what do I need to multiply everything by? 2, right? To go from 6 to 12, I need to multiply by 2. So this equation I got is a good starter, but in order to get the right answer, I have to multiply everything by 2. Okay? So that the actual function that I get is 2x to the third minus 10x squared plus 4x plus 8. Does that make sense? Okay. We are going to finish 3.4 tomorrow because we don't have enough time before the bell rings to talk about dequatorial signs. Okay? If you're so mad about this, which it appears that you are, I know how you're excited about that doing. Yeah, just watch your mouth. I don't want to hear you say cheese and crackers. You can actually look this up on your own on the interweb because there's places that talks about it. Okay?